Hello everyone. So, this is the fourth lecture in week 2, introduction to Python. So, recall that in the last lecture we discussed about insertion and deletion of elements in a one dimensional array and insertion and deletion of rows and columns in a 2-dimensional array. And we also discussed about arithmetic operations, and I mean finally we ended with the commands to compute the shape of a matrix, that is the size of the matrix as we would usually call it, or the number of dimensions, whether it is a 1-dimensional array or 2-dimensional array or 3-dimensional array, whatever. Okay. So, we will continue. Okay. So, now given an array, you actually want to find the sum of the elements of an array. Okay. So, we have an array V already. Okay. So, I will just write print of V so as to let you know what it is. And so, let us say I want to find the sum of the elements of this array. Okay. So, yeah, if you had an experience in coding in say C or C++ for example, you would write a loop for finding this, right. So, Python has it much easier. You just write np.sum of v, and yeah, you will get the sum. Okay. And if you want the product, okay, so that also is very simple. You just write np.product of v. Okay. So, yeah, that is 10 factorial, you can compute that to be 36,28,800. Okay. You can find the average, that is np dot mean of v. You can find the median, which is np dot median of v. Okay. Yeah. So, both are 5.5, no questions on all of that, right. So, yeah, these are some simple commands where you can find the sum, product, mean, median and so on. Okay. And so, the other operation that you might like to see is the norm operation of a vector, right. So, yeah, if you are sharp enough, you would have figured out that you can multiply the elements by itself, right, and then sum the elements, right, and finally take the square root. Okay. You can certainly do that. Okay. What I am saying is you can do the following. You can do np dot, yes, so square root is something that I have not defined. So, np dot sqrt takes the square root. Okay. So, I mean to illustrate that, I will write that in the next line. So, suppose you want to print the square root of 2. Okay. So, yeah, it gives you 1.414 whatever. So, what is norm? Norm we all know is the square root of the sum of the element wise product of the vector with itself, right. So, if you do this, you will certainly get the norm of this particular vector. So, it is just 1 squared plus 2 squared plus dot 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 plus 10 squared, the whole square root, right. So, that is correct, but there is also a simpler command. Okay. And what is that? It is np dot linalg dot norm of v. Okay. You can see that both of them are the same. Okay. So, what is linalg? Linalg is linear algebra. So, it is a sub library of NumPy. Okay. So, you are actually trying to find the norm of a vector, and yeah, so you can use something called linalg for this. So, I mean norm is something that is more used in the linear algebraic sense. So, that is why it is actually placed in the linear algebra sub library of NumPy. Okay. So, this is another command that you should be knowing. Okay. And the other important command is the dot product. So, suppose you want to take a dot product of V and W. So, yeah, okay, then I will print W also for you. W is just the reverse of V. Okay. Yeah. So, that will be 1 into 10 plus 2 into 9 plus dot 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 10 into 1, right. So, or you can see you can sum up these elements. Okay. So, you will get 220. So, this is 28, 52, 80 and 110. So, this is also 110. So, you get 220. Okay. So, yeah, this is the dot product of V and W. So, you just use the simple command np dot dot of V comma W. Okay. In a similar way, we have certain matrix operations that I want to illustrate as well. Okay. So, how do you find the determinant of a matrix? How do you find the inverse of a matrix, and how do you find the rank of a matrix? Okay. So, I will just illustrate these three. You can do more things like eigenvalues, singular value decomposition and many more, but that is not required for our course. Okay. So, yeah, let us I mean I will print M, so that you understand that this is for M, and I will now print the inverse of M. Okay. So, M is not invertible unfortunately. Okay. So, yeah, then in that case I will write down another matrix, or rather, okay. So, yeah, I will write n equals M plus np dot I of 3. So, this command, right. So, this is actually the identity matrix of order 3. So, for identity matrix we write I, capital I, right, but so I mean that has been translated as EYE, np dot EYE. Okay. Yeah. So, that is how we write it. So, I will also print that, so that you understand what np dot I of 3 is, and n I am writing it as M plus np dot I of 3, and I am finding the inverse n. Okay. So, again I will also print n for you. Okay. So, you can see that M is our usual matrix 1 2 3 4 5 6 7 8 9. I of 3, as you can see, is 1 0 0 0 1 0 0 0 1, and M plus I is just, so this is 1 becomes 2, 5 becomes 6 and 9 becomes 10, every other element remains the same, and the inverse is so this is actually 0. So, yeah, but it is so small, so it is written as 10 power minus 16, but the others are nice elements, minus 6, minus 2, 3, minus 1, half. So, this is half, 0, 5, 1 and minus 2. Okay. So, yeah, this is how you find the inverse of a particular matrix. It is just np dot linalg dot inv. Okay. And how do you find the determinant? So, it is just np dot linalg dot det of n. Okay. Or yeah, I will also find the determinant of M, okay, and the determinant of I of 3 for you, so that you get convinced that I am my answers are possibly right. Okay. Yeah. So, for n it is minus 2, and so yeah, this is an anomaly. Okay, leave it. And for M it is 0, which I told you in the beginning, and identity matrix we all know that the determinant is 1. Okay. All right. So, that is inverse determinant, and if you want to find the rank, it is np dot linalg dot matrix underscore rank. Okay. So, it is not just rank as we would have expected it to be. So, yeah, you can find it for n as well as m. Yeah. So, since the determinant of n is non-zero, so the rank is 3, and here it is 0. So, you can see that the rank is 2. Okay. So, yeah, these are some of the operations, and yeah, one more very important operation I should have told you in the beginning is the transpose of a matrix, right. So, that is a very simple operation. You just write m dot capital T. Okay. So, that gives you the transpose. You can see that it is 1 2 3 4 5 6 7 8 9. Okay. Yeah. So, yeah, the transpose is very simple, it is just dot capital T. Okay. So, I mean that is how you write the transpose of a matrix, right, a T at the top. So, here it is a dot and a T. So, you just write m with a capital T at the top, right. So, instead you are writing dot capital T. Okay. So, yeah, these are some of the matrix operations. Okay. So, yeah. So, yeah, we did arithmetic operations on an array, and we also did yeah, certain commands like sum, product, mean, median, and norm. Okay. So, yeah, these were some of the operations that we did in an array, and in matrices we saw transpose, and we saw rank, we saw determinant and inverse. Okay. So, I think these are sufficient for now. Yeah, you do not need any more for at least for this course. Okay. So, we will now move ahead to what we call as the conditional operations. Okay. So, yeah, so I mean we have conditions to implement when we are writing a code, right. So, if something is right, we do this, and if something is I mean if a condition is satisfied, we do something, if the condition is not satisfied, we do something else, right. So, those are actually called as conditional statements. Okay. So, start with conditional statements. So, conditional statements are use if, elif and else. Okay. So, I will explain what these actually mean. Okay. So, let us say you want to find whether so you have two numbers, let us say a, b, which is 4 and 5. So, you want to print you want to find whether a is big or b is big. Okay. So, how do you do that? You write if a greater than b, then print a is big. Okay. Else you print b is big. So, here you can see that a is 4 and b is 5. So, obviously b is big. So, you can see that it prints b is big. Okay. So, yeah, before I proceed further, I would like you to look at the syntax. Okay. So, if you have I mean if you want to write if, okay, so you write it as if statement 1 with a colon at the end. Okay. So, when you write the colon, it means that the statement ends. Okay. So, if you do not give a colon, then Python will actually give you an error. Okay. All right. And you can also see that in the next line I have an indent. Okay. I have some free space in the beginning, okay. And then I am writing print a is big, I mean whatever commands that need to happen when a is greater than b, right. So, this indent is something that is very important in Python. Okay. So, if you have learnt some other programming language, let us say C for example. So, you would actually have an open braces and a close braces, right. So, if some statement open braces, that means the statement starts from there, sorry, I mean what you the routine what you need to do when the condition is satisfied, it starts from the braces and it ends when you close the braces, right. So, that is how you do it in C. If it is in MATLAB for example, you write an end at the end, right. So, you have if some statement, so you write the routine and then finally say end, right. So, here you do not have such open braces, close braces, or you do not have an end statement. Instead what do you have? You have the free space at the beginning of each of these lines. Okay. So, you can write 10-15 lines whatever you want, I mean the routine, okay. But when the routine ends, you end the indent as well, the free space gets closed. This is something that is very important. So, here in Python indent is very important. So, in other languages let us say C or MATLAB, even if you leave many spaces it does not matter, but here the space at the beginning is very important. It means you are actually committing to an indent or not committing to an indent, that is very important, please keep this in mind. Okay. So, yeah, if you want me to write this as a syntax, it is if condition a colon and then a space. So, then you write command 1, command 2 dot 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 command L, okay. And if the routine completes here, you come back, okay, and then you write else here. You can write the other commands, command L plus 1 to command L plus m, okay. And if the else routine ends here, you come back to write the next statement here. Okay. So, this is very important. Okay. So, yeah, so this is when when you want to compare two numbers a and b. So, I can reverse this, let us say 5 comma 4, you will see that a is big as well. Okay. So, nothing fancy about this, but now what if I write 5 comma 5. Okay. So, it still says b is big, which is not exactly correct, right, because a and b are actually equal. So, why does this happen? So, what it does is if a is strictly greater than b, then it goes in here. If it is not strictly greater than b, it comes to else statement. Okay. So, that is why you actually see b is big. Okay. So, if you want to avoid this, okay, so you have to write another statement, elif a equal to b, print A and B are equal. Okay. So, now what is this elif? Elif means else if. Okay. Suppose you have more conditions. So, this is when one condition is satisfied or not satisfied, right. Instead you might have something of this sort. For example, you have if condition 1, then a routine, okay, of several commands. Then you want to see if condition 1 is not satisfied, I am going to check condition 2, right. So, then you write else if. So, else if, the short form in Python is elif, ELIF, okay, elif condition 2, another routine. So, I will write it as routine 1 and routine 2. So, I could have more conditions as well. elif condition 27, okay, just for the sake of it, routine 27, and the finally you can write else. So, if none of these conditions are satisfied, then you have the final routine. Okay. So, yeah, that is why this statement elif is important. And another thing that you must have noticed is that I am not writing A equal to B, I am writing A equal to B. So, equal to is for assignment, equal to is for verification, for checking. Okay. So, I mean I can write this as well, equal to is for assignment and equal to is for checking. Okay. Okay. The other conditional operators are greater than, less than. So, greater than or equal to is not something that you can write in the keyboard, right. So, we use this greater than equal to and less than equal to. Okay. So, these are conditional operators. So, you also have logical operators, okay, which is or and. Okay. So, there is one more conditional operator which is not equal to. Okay. I am sorry. Okay. Okay. So, that is you write an exclamation mark with an equal to. Okay. So, for example, you can write so let me modify this a little bit to illustrate what I want to illustrate. So, I just want to say if A not equal to B, then they are unequal, and if it is not, then they are equal. Okay. A and B are equal. So, here they are equal. So, you can see that in this case they are equal. So, suppose I change it to 4, then they are unequal. So, you are just verifying if A is not equal to B. So, that is exclamation mark with an equal to. Okay. So, fine, that is one more that I wanted to illustrate, and you also have or and as logical operators. Okay. So, suppose I want to check multiple conditions on the same line. Okay. As an example, let us say I want to check which of the 3 is big. Okay. So, in that case I want to write it like this: if A greater than B and A greater than C, print A is big, else print A is not big. Okay. Yeah. So, of course, here A is not big. So, you can see that you are writing two statements with an and. Okay. That means both the conditions have to hold. If both A is greater than B as well as A is greater than C, okay, then I will write A is big, then I mean otherwise I will not write that. Okay. So, now what is what happens with OR? It means either A is greater than B or A is greater than C. Okay. So, in that case I will write A is not small. Okay. So, since at least it is greater than one of them. So, if this is not true, then A is small. Yeah. Yeah, in this case A is small because A is neither greater than B nor greater than C. So, A is actually the smallest, right. So, these are actually called as logical operators, and yeah. So, you write them using OR and AND. Okay. So, these are logical operators that will be useful when you want to verify certain statements. Okay. And yeah, so this is all I want to say on conditional statements. In the next lecture we will look at loops and functions. Okay. So, all right. So, let us end this lecture.